Hi folks, and welcome to a short video working through two examples of binomial expansions to help you do the second half of exercise 4a. Example 1. fx equals 3 plus 2x over the square root of 1 minus 4x. Expand as a series up to the term in x squared and state the range of values of x for which it's valid. So what we're going to do here is we're going to rewrite this expression as 3 plus 2x multiplied by 1 minus 4x to the power minus a half. So the square root of 1 minus 4x is 1 minus 4x to the half. The fact it's in the denominator makes it to the power minus a half. And this will be approximately equal to 3 plus 2x multiplied by the expansion of 1 minus 4x to the minus a half. I put approximate because I'm only going up to terms as high as x squared. So I want 1 plus nx to start with. 1 plus, now my n is minus a half. And my x is minus 4x, because you've got to think in the bracket as 1 plus x. So it's like 1 plus minus 4x. And then the next term will be minus a half times minus 3 over 2, 1 less than minus a half, over 1 times 2 minus 4x squared. So that gives us 3 plus 2x, 1 plus 2x. Now what have we got for this next one? We've got 4 negatives involved, because the bracket squared gives you 2, and then there's 2 in the numerator there. And what can I see? I can see 2 times 2 times 2 in the denominator, which is 8, but the 4 squared in the bracket will give 16, so 16 over 8 is 2, and I still need to multiply by the 3, so that becomes a 6x squared. And now I multiply this out. 3 times 1 is 3, 3 times 2x is plus 6x, 3 times 6x squared is plus 18x squared, sorry. And then 2x times 1 is plus 2x, 2x times 2x is plus 4x squared, but I stop there, because if I multiply the last bit, 2x times 6x squared, I get 12x cubed, but we're only going as far as x squared, so we can't include some x cubes. There would be other x cubes. If I had gone to the next term, the 3 at the very front would have been multiplied by that, so 12 x cubes wouldn't be the right amount of x cubes if I just put it in now. So stop when we get to x squared. And this is approximately 3, 6x plus 2x is plus 8x, and 18 plus 4 is plus 22x squared. So that gives us the expansion up to the term in x squared. And it would be valid for the modulus of minus 4x being less than 1, which is basically x is between, dividing through by 4, it's between a quarter and minus a quarter. Or you could say mod x is less than a quarter. Right, now I'm going to ask us to evaluate this at x is 0.1. So 3 plus 8 times 0.1 plus 22 times 0.1 squared. If we put that in the calculator, we get 3 plus 0.8 plus 0.22, which is 4.02. Now, if we put 0.1 in the original, in our calculator, that will be 3.2 on the top divided by the square root of 0.6 on the bottom. 3.2 divided by the square root of 0.6 is equal to a calculated value of 4.131182236. And so our percentage error would be 4.131 4.02 minus 4.131182236 divided by 4.131182236 times 100. What am I doing there? Well, the actual error is 4.02 minus the correct value, and then to express it as a percentage error, I divide that error by the real value times it by 100 to turn it into a percentage. So 4.02 minus the answer on my calculator and divided by 4.131182236 times 100. So that gives me equals minus 2.69%. So the negative sign just means that we got an answer lower than the true value. So 2.69% percentage error. Now a second example. Find an expression for 3 over 1 plus x minus 2 over 1 minus x, an expansion for that as far as x squared, and state what it's valid for. So this time what I'm going to do is I'm going to keep them separate to start with, and I'm going to say 3 times 1 plus x to the power minus 1 is equal to 3, or it's approximately equal to 3. 1 plus nx is 1 minus x. Then I want minus 1 times minus 2 over 1 times 2 x squared, and that's as far as I'm going. So that's 3, and I've got 1 minus x plus x squared because the 2's cancel, which is 3 minus 3x plus 3x squared. So let's call that A. And the other one is 2, so I'm ignoring the minus sign at the moment. 2 times 1 minus 2x is approximately 2 times 1 plus nx will be 1, sorry, this is the power minus 1. This will be 1 plus minus 1 times minus 2x plus minus 1 times minus 2 over 1 times 2 my x squared, and that's as far as we're going. So that will be approximately 2 times 1, and then I've got plus 2x. Sort out the next one. There are 4 negatives, so it's going to be positive overall. The 2's cancel out before the bracket, but I'll have the 2 squared in the bracket, so it's going to be 4x squared. So that comes to 2 plus 4x plus 8x squared. And we'll call that one B. Now we want that first term minus the second term, so we want A minus B. And so I'm trying to take the second bracket away from the first. So 3 take away 2 is 1, minus 3x take away plus 4x is minus 7x. 3x squared minus plus 8x squared is minus 5x squared. And so that is our expansion for what we were asked to find. Just remains to declare which range it's valid for. So the expansion of 3 over 1 plus x is valid for mod x is less than 1. But the other one, 2 over 1 minus 2x, is valid for mod 2x being less than 1, which is mod x is less than a half. Now if this expansion is going to work, it has to work for both parts, so you've got to take the most restrictive one. You can't go for mod x is less than 1 because it wouldn't work for the second one. Overall, mod x is less than a half, or we could say x is trapped between a half and minus a half. And that brings us to the end of the second example, and hopefully that will give you some help to tackle some questions in the second half of exercise 4A.